Hi there, Tutor Bedingo here. Welcome to today's session. Alright, so in today's session, in our series of videos meant to help the grade 12s prepare for their exams, we are solving question 4A from the paper 2024 Mathematics Paper 2 internal. So this is a question, the first part of the question is on matrices, then the second part is on geometric progression. So the first part says, given that matrix P is equal to that matrix there, find its determinant. Okay, so the formula for the determinant is, we're trying to find matrix P, the determinant for matrix P. So you can write it as determinant of P, or you can simply express it that way, which is what I'm going to do up there. Let me express it properly. So I'm going to say, first of all, I need to indicate the question number. So that is question 4A, Roman numeral 1, very important. So matrix P is going to be equal to AD minus BC, leading diagonal minus trailing diagonal. Okay, so this is our matrix, identical matrix. So I have A, B, C, and D. So this times this minus this times that. So it will be 3 times 2 minus this times that. Okay, so what is A? A is 3 times 2, which is a D. So I'm going to say A is 3 times the 2. Let's put these values in brackets and then we say minus. There's that minus there. Okay. And then there, since I have negatives, I'm going to express it that way. So I'm going to have this times that. So it's going to be negative 4. Okay. Times, I can simply do this. Okay. Negative 4. So remember the formula is BC. So meaning B times C. So it could be this times this or this times that. So negative 4 times negative 1. And then we can simplify. So we're going to now say the determinant is going to be 3 times 2. It gives us 6 minus. And then in brackets, negative times negative, it gives us a positive. 4 times 1 gives us a 4. Then we can open the brackets. Negative times positive is negative 4. So our determinant is therefore going to be 6 minus 4, giving us a 2 as our determinant for that particular matrix. Okay, so the next part of the question is asking us to find the inverse of the matrix. So inverse is represented by a negative 1 power. Okay, so that is our inverse. So the inverse is equal to 1 over the determinant of matrix P times the adjoint, okay, of matrix P. What is the adjoint? For the adjoint, you simply get the original matrix, you swap these values, the values of the leading diagonal. So there where there's 3, we're going to put a 2. There where there's a 2, we're going to put a 3. And then we multiply these with a negative. So we simply change the signs of those values. So it's going to be adjoint of, it's actually supposed to be a capital A there. So adjoint of P is going to be equal to, so here where there's 3, we're going to put a 2. There where there's a 2, we're going to put a 3. And then here we change the signs of these entries. So if this one is a negative, we're going to make it a positive. This one is a negative, we're also going to make it a positive. So this is our adjoint. So I'm simply now going to solve by saying the inverse of matrix P is going to be 1 over, what is the determinant? We found the determinant as 2. So you say 1 over 2 times, what is the adjoint? The adjoint is there. So we have 2, 4, 1, and 3. So this is our final answer for the inverse of this particular matrix. Okay, we now go to question B, which is on geometric progression. And it says, given the geometric progression 10, 30, 90, find the 10th term. So in order for us to find the terms, we first need to find the common ratio. Okay, so the common ratio formula, that is question B, Roman numeral 1. The formula for finding the common ratio is T2 divided by T1. So what is term number 2? Term number 2 is 30 divided by term number 1, which is 10. So it's going to be 30 divided by 10. Okay, the zeros cancel. 3 divided by 1, 3. So our common ratio is 3. Now that we have found the common ratio, we can now find the 10th term. So we're going to say, therefore, term number 10 is equal to AR n minus 1. So T10 is going to be equal to, what is our A? A is the first term, which is 10. So we're going to say 10 times the common ratio. We found the common ratio as 3 to the power n. Okay, n is the term you're trying to find. If you're trying to find the 20th term, then your n becomes 20. If you're trying to find the 12th term, your n becomes 12. Since we're trying to find the 10th term, therefore our n becomes 10. So we're going to say 10 minus 1. Okay, so we're going to now say T10 is equal to 10, open brackets, 3 to the power 10 minus 1, 9. Okay, can now bring it there. So we're now going to say T10 is equal to 10, open brackets. What is 3 to the power 9? You can now use the calculator. Remember, this is paper 2. We're free to use the calculator. So 3 to the power 9 gives me 19683. 19683. 3 to the power 9. Okay, 19683. And then 10 times this, we simply add the 0 there. So meaning the 10th term is going to be 196, 830. Okay, whenever you're multiplying any value by a 10, you simply add the 0. So that is going to be our 10th term. We now come to the sum of the first 6 terms. So now there are two formulas for finding the sum of the terms. What determines which formula you are going to use to find the sum of the terms is the common ratio. Okay, so at the beginning of the exam paper, actually on the second page of the exam paper, where you find formulas, there's a formula there for finding the sum of the terms, and for finding the terms even, I think it's there also. Yeah, so there are two formulas there. So the first one, Sn is equal to A, open bracket, R to the power n minus 1, close, everything over R minus 1. So use this formula when your common ratio is less than 1. Okay, and then the second one, Sn is equal to A 1 minus R to the power n, close, everything over 1 minus R. So use this one when the common ratio is greater than, wait a minute, I think I've switched them around. So use this formula when the common ratio is greater than 1, and then use this one when the common ratio is less than 1. So now, what are the numbers that are less than 1? All fractions are less than 1. So whenever you have a fraction as a common ratio, it means that common ratio is less than 1. Therefore, this is what you're supposed to use. Okay? This implies that the common ratio is less than what? Is less than 1. So our common ratio, when we solved, we found 3. Okay? So the common ratio is greater than 1. You can see here, R is greater than 1. Okay? So meaning this is the formula we're going to use because the common ratio is 3. And 3 is greater than 1. So I'm therefore going to say that is question B, Roman numeral 2. Since the common ratio is greater than 1, this is the formula we're going to use for finding the sum of the terms. So we're going to say Sn A R to the power n minus 1, close, everything over R minus 1. So there's actually no need for you to actually master these formulas because they're given to you in the question paper. Alright, so we simply plug in our values there. The first term is 10. According to that sequence, our common ratio was 3. What else do we need? We need n. Okay, what is our n? What is the question asking us? Find the sum of the first 6 terms. Since we're finding the sum of the first 6 terms, our n becomes 6. If you are finding the sum of the first 10 terms, our n becomes 10. If you are finding the sum of the first 50 terms, our n would have been 50. So we simply plug in those pieces of information into our formula, and then we are good to go. So sum of the first 6. So there, we're going to put 6 where there's n. So wherever there's n, we're putting a 6. What is a? A is the first term, which is a 10. What is r? R is 3. 3 to the power n. What is n? 6. Okay, 3 to the power 6 minus 1. Close. Everything over. What is r? 3 minus 1. So sum of the first 6 terms is equal to 10. Open bracket. Okay, what is 3 to the power 6? You can use our calculator there. So 3 to the power 6 gives me 729. 729 minus 1. Okay, everything over 3 minus 1 gives me a 2. So sum of the first 6 terms is going to be 10 times 729 minus 1 is 728. Okay, everything over 2. Sum of the first 6 terms, when we multiply this by 10, we simply add a 0. So it becomes that divided by 2. So sum of the first 6 terms would be this value divided by 2. What do we get? So 7280 divided by 2, it gives me 3640, 3640. So this is the sum of the first 6 terms, and you are done. We now go to the last one. So the last one says find the geometric mean of this and that one. So for this one, I don't know if the formula is given in the question paper. If it is not given, then make sure you know it. Okay, so that is Roman numeral 3. So we say b is equal to the square root of AC. That is our formula, where a is the first value they give you and c is the last value they give you. Okay, so b is equal to the square root of what is a? That is 2430 times, these values are multiplying, times 21870. Is it correct? Okay, then we find the square root of those values. Okay, so what is 24 times 2430 times 21870? 2430 times 21870. 2430 times 21870 gives me this big value, 53144,100. Okay, so we have that there, 53,144,100. All right, so now what is the square root of this value? So the square root of 53144,100, 53144,100 is 7,290. 7,290. So that is our final answer on that one, and you are done. So that is all I had for you in today's session. Tomorrow morning at 5 hours, I'm going to share another video which is going to be on construction. So remember, our goal is to solve 4 exam papers, complete exam papers, and we are sharing videos every single day, one at 05, the other one at 18 hours. So if you know anyone who is doing who is in grade 12 or who is writing next year in 2026 GCE, you can invite them over to this platform so that they can also benefit from these lessons. Otherwise, thank you for watching. Remember to give it a like if you found this video beneficial, and remember to follow the platform or subscribe